Okay, hello everyone, and welcome to this sixth day of 1 week international e-workshop on geospatial technology. So we have today we have the first lecture on remote sensing and application of remote sensing and GIS. This will be delivered by Dr. MINA BABAZADEH, and before this lecture, she has also delivered one lecture on geospatial analysis. I'm telling something about her that she has done her PhD in geography from Jawaharlal Nehru University, Delhi, India, and uh, she has uh, she has been a lecturer at Geospatial Mapple Technology Department of Geography, MLK PG College. She is a researcher associate at Policy Change Initiative, and she is a joint researcher at Climate Change, Environment and Suitability Development, Jawaharlal Nehru University. So over to Meena.
Thank you, Saba. Thank you so much. So I'm happy to deliver second lecture. I hope it will be, students can use this lecture to get a better view about GIS application. So let
Definitely.
me share I'm sharing the PowerPoint. So everybody will, today we want to talk about application of remote sensing and GIS in various fields. So GIS, what is it? And definitely for today, there is no easy answer about it. Geographical or geospatial information about places and the Earth's surface, knowledge about what is, where and when. Geographic or geospatial. GIS, what is in S? Maybe systems that is showing us technology, science, yeah, maybe that concept and theories definitely is include, and studies, yeah, that is socio-ethical context. So definitely for the GIS we need remote sensing data as well for so many applications also. One is remote sensing. There is useful information about the object on this earth, and then with help of GIS, that is already a system that deal with all type of geographically referenced data. As you can see, on earth we have different features that can be about land cover, it can be about soil, water, hydrology. That with the help of GIS and remote sensing we can have a better understanding about each features. Geographic Information Technologies Global Position System (GPS), a system of the Earth orbit satellite which can provide prices, location on the Earth's surface. Remote sensing, use of satellite of aircraft or capture information about the Earth's surface. Digital or image, a key product. And Geographic Information System (GIS), software system with capability for input, storage, manipulation, analysis, and output, display or geographical information. Why study GIS? 80% of local government activity estimated to be geographically based, like zoning, public work, garbage collecting, land cover, land use change in the city, public safety, so they use GIS method. A significant portion of state government has a geographical component, like natural resource management, highway or transportation. Business, definitely for the recently they start to work for the business. They use GIS for very wide variety of applications. Military and defense, yeah, for battlefield management, for satellite imagery interpretation, we need this GIS. For scientific research, definitely we use GIS for geographical, geology, anthropology, sociology, economic, political science, and epidemiology, criminology. We can use GIS method. What GIS application do? Manage, analyze, and communicate. Make possible automation of activities involving geographical data, map production, yeah, calculation of area, distance, route, roads, measurement of slope aspects, view of shape, and logistic, yeah. For the planning, vehicle tracking, we can use GIS. With the help of GIS, we can have a independent domain about our area, and for the complex spatial patterns, for communication, for spatial modeling, for spatial queries, we can use GIS. The GIS data model, what is the purpose? Allow the geographical features in real-world locations to be digitally represented and stored in a database so that they can be abstractly presented in the map form and can also be worked with the manipulator to address some problem. As you can see, here we have our map that is from our real world, our real location, that has different features like buildings, urban area, natures, water, river around some rivers, sea, depending on which part of area we selected. This is map of with what kind of area. Is it natural area? Is it city area? And then what kind of information I can get it from the space that has a different layer, and with the help of this layer I can make a proper map out of it. So the GIS data model implementation, geographic integration of information. So what kind of information? Like building, hydrography, street, digital of our roads, river, any feature in the earth can be come under map. Data is organized by layers, coverage, or themes, with each layer representing a common feature. Layers are integrated using a specific location on the earth's surface. Those graphical location is organized principles. The GIS model example. So here we can see, as I said, for the road, suppose, definitely we need the longitude and latitude. Here we are three layers of them, road, hydrology, and topography. They can be related because of the previous geographical coordinator. Layers are combined from different area, different data. Maybe one area has 2-3 datas, different datas. That is spatial data which describe locations of each element. Attribute data specifying what, how, much, and when. Layer may be represented in two ways, in vector and in raster format. All graphic data has four properties: projection, scale, accuracy, and resolution. Spatial and attribute data can be spatial data where attribute descriptive data what, how much, and when. And with this help of this element, GIS system can maintain spatial and attribute data separately that can, with joining them, we can display or analyze. Representing data with raster and vector method. Raster model. Area is covered by grid with equal size. So it depends on the satellite we use, so size of cell is different. So, and then with attribute are recorded by different cell and single value based on the majority of the features in the map, in the cell. Image data is a special case of raster data in which attribute is reflected value from the geometric spectrum. And vector model. With vector model, we can point or dots, make a point or dot in our maps, or make a line according to our feature, or we can specify the area by making polygon around our area. So as I explained, concept of vector and raster. This is the raster representation from the one satellite. So each cell has some data on the earth that this data can be represented by vector data by point, line, polygon. And out of these two, we can make a real world by map. So as we can see, dumb image or a smart image, by this kind of information of our raster and vector data, we can find number of each cell, and then we can make a proper map of the area. Projection, scale, accuracy, and resolution. What projection can do? Projection is a method which cure 3D surface of our Earth, represented by X and Y coordinate. Scale, the ratio of distance on the map to the equivalent distance on the ground. And accuracy, definitely, we have to know what kind of data we find, how much is accurate on the Earth, how well does it database info match to the real world. And resolution, the size of the smallest features able to be recognized. So some of the example is like, if we can see, this is a layer of vector layer in the GIS. By help of this raster layer, we can digital our photographic map layers and maps, and digital them to the proper map. So you can see this base of common geographical locations. As by the help of map, we can find the exact geographical location of each element, each features in the map. Definitely, with this help from map, we can find the proper data for each cell. With help of these elements and the number of the element they are giving to us, number of the each cell, we can start to analyze. Suppose for one area, I want to know how much is the land cover. Amount of number here they are giving to me, I can find how much change detection is happening for the land cover. So thank you, Saba. Hope it was helpful for students. Although I believe that they have to learn GIS practically, as everybody try to read and listen different lecture about GIS, but I believe with doing different projection, they can understand well.
Of course. Of course. Thank you, Mina. Thank you for delivering such a wonderful and informative lecture. I hope the participants will learn from this lecture and get benefited. Thank you.
Most welcome, Saba.